Welcome to the Box of Textures. This is the Tangram sequence from the 1980 Tangerine Dream album of the same name. And I did a video about this previously in Voltage Modular, the same program that we're in now. But I did it using all sorts of digital modules. 3 digital sequencers, another sequencer to sequence the other sequencers, various digital clocks to run everything and keep it all in sync. And it was great fun, and it was amazing to actually hear the sequence that I had made myself. And that was great. And end of story, except just recently, and this is the 4th video I've done on the Voltage Modular VM900 Moog-style module collection that they just released. So I did these other videos and played with the sequencer and the modules and had a great time, and then I'm just sitting there and I realized that I could do the Tangram sequence possibly the way Tangerine Dream did, using old-style, primitive, non-digital technology. So here we are. It was fascinating putting this together. It's all analog. There's no digital timing or routing or anything. You know, the way they originally did it in 1980 was just crazy original and just an inspired use of these analog sequencers. And I know they had all kinds of custom units built for them, but that is not the point. But we're going to go old-fashioned Moog modular style and take a look at this sequence. So first off, this entire bottom row can just be ignored. In a sense, that is the synthesizer. I've got the 920A BBB voltage-controlled oscillators. Basically, it's 3 oscillators with a controller attached to it. That goes into a mixer. Nothing fancy, just triangle waves. And in fact, I'm only using 2. Envelope generator through an attenuator, because you need attenuators, into the filter, and I'm using a bandpass filter, out of the filter into a voltage-controlled amplifier with its own envelope generator and attenuator as well, and the Moog reverb unit, which honestly, I can't speak for the original, and I also can't speak for how accurately this reverberator unit emulates that. Nothing personal, Cherry Audio, but it's a delightfully terrible reverb. I mean, it's not your 21st century digital reverb that's smooth and nice and everything. It's not that it's hilariously bad, but it's just, you know, it's part of that 70s or even 60s era sound. So I love it. It's the only effect that is included in the VM900 collection. So in a way, I feel almost obligated to use it. But if you bypass it, it actually, you can hear that it does a heck of a lot, even for, a weird reverb. It just has that 70s, 60s springiness to it that I just kind of love. So anyway, all that about the bottom row, we are just going to ignore it because it is neither here nor there. So let's take a look at what we've got. I set up a couple of buttons at the top, and let us turn this sequence off. And this is a reset button. So first off, the 960 sequential controller module, or otherwise known as a sequencer, I have put in the notes, voltages times 2, and there are 7 notes in the sequence. One of the other cool things about doing this with a digital sequencer is you can just say, this is an A3, this is an E5. You cannot do that with the Moog-style sequencer. You have to put in the voltages. So that is what I have done. And it's 7 steps. I'm going to disable the second sequencer. So let's start this off. So what we have is 7 notes in row A, and those are the first set of notes in the Tangram sequence. And each set of notes in the sequence plays twice, and we're going to use the sequential switch to manually move to the, hopefully in rhythm, to move to the second row of knobs. Got it. And we'll do the same for the third one. Okay, that is, I actually did it, shockingly, but it's a little bit hair-raising because you have to get the timing right. You don't want to come in late and have it start at the second note because that'll blow your whole thing. So we do not like having to switch these trigger inputs. Let me take a brief step back. This is the output of row A goes to signal input 1, the output of row B goes to signal input 2, and the output of row C goes to signal input 3. So what we're doing here is we're manually selecting which of the 3 rows is going to go to the output. And so they're all 3 rows playing simultaneously, but we're only sending one set of those voltages to the output. And that output goes to the voltage control oscillator, and that's what gives you the individual notes. But we don't want to manually press these buttons, but handily there are trigger inputs. So when we send a voltage into this, we send a trigger voltage in here, that will automatically advance it to the next. So whichever one gets a voltage is the row that you will hear. So let's take a look at this next sequencer. Just note that we are not using the second sequential switch for anything in this particular patch, but I figured I would put it in. What I actually want to do is build a Moog 3X modular with the sequencer cabinet on top and have just the modules that came with it stock. And I'm considering building a Moog 55 as well, but I've always wanted the Moog 3 whatever, 3C or the 3P for portable. I'm maybe messing up the naming there, but for now I just wanted to get this Tangram sequence going. So let's take a look at this. In order, well, let's go a little further back. We have the clock, or the oscillator output, and that is triggering the gate inputs on my envelope generators. It's internally also wired to move the sequencer to the individual steps. So whatever the clock speed, which is set by the frequency range and the frequency voltage, that is what goes, how fast the sequencer runs. So clock pulse 1, we play note 1. And currently, we're going through output. We're using signal input 1 and sending that to the output. So you get this voltage, a clock you get this voltage, a clock you get this voltage, and it keeps going until this step, and we're skipping step 8, so it cycles back around. So 1 through 7, back around. What happens here, this output, we could have picked the output from any step, but every time you hit step 1, the sequencer goes, aha, and it sends a voltage, a clock pulse out on this output, and that is going to the shift input of the second sequencer. And what the shift input, what the shift circuit does is every time that gets a pulse, or a trigger, I suppose, that moves the sequencer one step. So in a sense, these two sequencers are synchronized. But what happens is this plays sequencer A, the first sequencer, plays through row 1. It hits note 1 of that row, and it sends out a pulse. That pulse moves sequencer B, the second sequencer. It says, aha, I've gotten a pulse, let me advance to the next step. Then the first sequencer plays through the row of notes. When it circles back to the first note of that row, it sends out another pulse, and that tells the second sequencer to move to step 3. So every time we complete a row, we're advancing the second sequencer. And what we've done here, we've done the exact same thing. So we're not using any of the voltages. If you notice, these are all empty. We're not using any voltages. We're only using this for triggers. So in the same way, we're taking the output as soon as this hits step 1 of the sequence, it sends a voltage to trigger input 1, which is telling the switch to take whatever is going on in this input and send it to the output. So here's how it breaks down. The reset makes this go to trigger input 1, this go to step 1, and this go to step 1. So everything is set to begin at the beginning. So when we press the start button, which is the same thing as the oscillator on of the sequencer, when we press the start button, this sequencer, this row plays through one time, circles back around. We get the clock pulse here, which moves this sequencer to step 2. Now, nothing happens on step 2. There's no output. So this row plays through a second time. As soon as we hit step 1, we send another pulse to the second sequencer, moves to step 3, except on step 3, we take the output pulse and send that to trigger input 2. That tells the first sequencer to send the output of whatever is in the second row of knobs, send that to the output. So that is how we change the notes. So we're running through row B. Actually, again, all three rows are running at all simultaneously, but we're only sending the output of row B. So it runs through once, hits step 1, sends a pulse out to the second sequencer. That advances to step 4, no output. So we're still on trigger input 2, which means row number 2 is still being heard. We go through all 7 notes. It circles around. On the first note, we send out another pulse. That advances to step, whoops, didn't mean to do that. That advances to step 5. Step 5 sees the pulse, sends it out, and that is connected to trigger input number 3, which shifts the output to the third row. So we go through the 7 steps of the third row, cycle back around. As soon as we hit step 1, that sends out a pulse. That goes to the sequencer number 2. There's nothing on step 6 here, so we go through it again. So this row plays, cycles back around. We hit step 1, sends the pulse out. We're now at step 7. It says, up, here we go. I see the pulse. I'm going to send a pulse to the trigger inputs. So now we're back to trigger input 2, which plays row 2. And essentially, we're just repeating this whole thing. So we play row 2 once, gets the trigger, sends to here, runs through, no change, we're still on row 2, runs through again, hits the trigger, comes through, and now we're back on step 1. Boom. Says, okay, now send the trigger to change the switch to use signal input 1. So we're back on row 1. So what we have is we play row 1 twice, row 2 twice, row 3 twice, and then we go back to row 4 and play that twice and start the whole thing over. So the beauty of this is they took a 3-row sequencer and an 8-step sequencer and used everything on both sequencers. Well, they didn't use the rows of the second sequencer, but they used the circuitry of the second sequencer. So 8 steps here, well 7 because we've skipped step number 8. So it's ingenious. They had the Moog modular synthesizers had 2 sequencers, and they used an unbelievably ingenious and clever patching to make the best use of both sequencers, and the end result was Tangram. I mean, when I figured this out, it was just, it was a sit back and shake your head kind of moment, because who knew? And I just loved it because, nothing digital. It's all analog. I've been using digital synthesizers for decades, and I do have some analog synthesizers, but, patch memory and recall and clock timing, everything is done digitally. And to be able to do these kinds of incredibly clever things at 100% in the analog realm, to me, is just mind-blowing. So there is one minor cheat in the way Voltage Modular has realized this. They give you quantized outputs and non-quantized outputs. It would have worked just as well in the non-quantized outputs, but using the quantized output it lets you pick the notes easier instead of being incredibly fiddly with getting the exact right voltages, and I was certainly willing to use that bit of cheating to get this done, but keep in mind that, in 1971, say, when Tangerine Dream was using Moog modulars in incredibly reverberant churches all through Europe, they did not have that luxury, so all the more impressive that they were able to get everything working properly. So I'm going to kick this thing off and sort of point as it goes along, and then I'll just let it run. So here we go. We're in row 1. It's running through twice. Now we advance to row 3. Now we dance back to row 2, circle around on the second sequencer. It goes through each row twice and then switches the outputs so we hear different notes, and then circles back around. Tangerine Dream, Tangram, 1980. That was so long ago, over 40 years, and the sequence still hits me as hard as it did back then. And before we go, the usual reminders to like, subscribe, join my Patreon so I can do tons more of these. I feel like I've only begun to scratch the surface of the VM900 set of modules. So far, I've been ignoring the synth aspect, more or less, and just been playing with the analog logic and the sequencers, but there's a ton more to be done with these, and I hope to have more videos on the Cherry Audio Voltage Modular VM900 series modules soon. Thanks.